So let's take a look at graphing polynomial functions, and we're going to start with our parent cubic function. I'm going to get my coordinate plane ready. When we want to graph a function, a good idea is always to use our 5 critical values for a table of values, and that will already help us to get a very good general idea about what the graph should look like. I'm talking about the numbers -2, -1, 0, 1, and 2. Choosing those numbers for x and plugging them into f of x. -2 cubed is -8. Remember, we're multiplying -2 by itself to get +4, then again by -2, and that makes the answer go negative again. -1 cubed, therefore, is -1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8. We can graph all these numbers now, but the most important ones for us would now be the ones here at the center. That's where all the important stuff is happening. So I'm going to plot my points -1, -1, 0, 0, 1, 1. And keeping in mind that that line is not straight, it's going to curve because the next value is already going up and down so much that I can't even fit it on this coordinate plane. I'm going to make this a nicely curved function, and this is what it would look like. Let's go ahead and find some of our function characteristics. The domain, well, if we see those two arrows that keep going forever, one towards the bottom left and the other one towards the top right, we can say that our domain goes from -infinity to +infinity. I'm writing this down in interval notation. Remember, parentheses is what we always use for infinity. And our range, again, for the same reason, and now we can show this in set notation. X is an element of the real numbers, is another way of saying all real numbers, of saying going from -infinity to +infinity. What's our end behavior? Well, as x goes to +infinity, f of x goes to +infinity, and as x goes to -infinity, f of x also goes to -infinity. Based on the graph of this function, the parent cubic function, we can now go ahead and pretty much graph every cubic function that we find. But first of all, let's look back at our quadratic functions and recall what all those different numbers, all those different components did to our graph. What did A do to our graph? A, being this number, is the dilation. In other words, it is what makes the graph shrink or stretch and also flip up or down. H, which is the opposite of this number here in the back, is the horizontal shift. In other words, right or left. And K, which is the number here in the back, is the vertical shift. In other words, up or down. Please make sure that you remember that H is really the opposite. Please write it into your notes right here. It's the opposite of the number that you see in your equation, so you don't get the horizontal shift wrong. So let's look at a couple of examples and use this newfound knowledge to graph our functions. We always start with our vertex, and this time the vertex is not at the origin. It is 2 steps shifted to the left and 1 step down. In other words, here is our vertex. And now, again, we only have to look at our dilation. The dilation is 3/2, or 1.5. It's still positive, but instead of going 1 step up, we now go up 1.5 steps. So I'm putting that point right here in the middle between the grid lines. The next one would already be way up, 12 steps up. But to the left, we also can mark down 1 step, and that is 1.5 down. And that will give us this point. Remembering that this is a curve, we can sketch it like that. And that's all we need to do. What can we say about the domain? Looking at it again, the domain is all real numbers. And the range, this time flipped set notation and interval notation, the range goes from -infinity to +infinity. Let's look at our end behavior. As x goes to infinity, f of x goes to infinity, and as x goes to -infinity, f of x also goes to -infinity. And going right to our next example, where am I going to place my vertex this time? This time I'm going to go 4 steps to the right. Remember, the opposite of what we see in that parentheses is really what h is. 4 to the right, 1 up. Here's our vertex. This time our dilation is -2. This time we have to flip, and we have to also go 2 times as far as we normally would. In other words, when we go to the right, we're actually not going up 1, we're going to go down 2. And as we go to the left, we go up 2. And that makes for a line which is stretched, still curved, but stretched. And this is what that graph would look like. Our domain is again from -infinity to +infinity. Our range is the same, all real numbers. Now the end behavior will be a little bit different this time. As x goes to +infinity, f of x goes to -infinity, and as x goes to -infinity, on the other hand, f of x goes to +infinity. That's it for today. Well done, guys, and I will see you in class.